Okay, so let's take a look. So remember, and you guys, have you done this before? Have you solved absolute value inequalities before? In the past? I think you did, but you may not remember. It's probably foggy at best, right? Click them all the way close, get everybody's attention up there. So it's the same kind of approach we take, not the same, it's very similar to the approach we take for solving absolute value equations. In fact, let's just review. Let's take a very simple one just to review the process. That's helpful to do, because then we're just going to extend that to inequalities. So what if we have something like, what if we had 3 times the absolute value of 2x minus 1 is equal to minus 2 is equal to 10. Okay, what are the steps I would follow to solve that absolute value equation? Add 2 and then what? Good, and the whole point of that is I'm trying to isolate the absolute value, right? So if we kind of group these steps, step 1, we add 2, and that gets rid of the 2, so I get 3 times the absolute value equals 12. Okay, then what? Then divide by 3. Okay, so there was step 1, and there's step 2. Okay, so the 3's cancel, and then I get the absolute value of 2x minus 1 equals 4, right? So we could classify that first part of the problem. This was the part where we were just trying to isolate the absolute value, right? Then what do we do?
I don't know.
Solve.
Oh, you split and solve.
Good. Okay, now here's where we have to trade it for 2 equations, because we can't do any algebra with the absolute value bars there, right? So we have to take whatever's inside now. Whatever's inside, and we're going to set whatever's inside equal to 4, or whatever's inside is equal to negative 4, right? And so this is kind of the trade part, right? So we isolate the absolute value, then we're going to trade the absolute value for the 2 equations. So the big step 2 here is 2 equations, right, that we're going to solve. And then we would just go through the process of solving those. I get 2x minus 1 equals 4, 2x minus 1 equals negative 4, and I just solve and I get 2 answers. No big deal, okay? So we're going to do the same kind of thing with inequalities, and I want to defend why that is. So here's a way to think about this. Now, we haven't gotten to the graphing part of the class yet, but we spent a little time with this group talking about what the graph of the absolute value function looked like, about a week ago or something-ish, maybe a week and a half, where we said this is the graph of the function. This is the graph of the function. Oh man, that's not all. This is the graph of the function y equals the absolute value of u. Right? It's just a v. Okay. So these would be the places right here and here. If this is a y value of a, right here. So let's say this is the line y equals a. These would be the 2 places where on that absolute value graph, its y value would be a, right? We get 2 points, and the coordinates of each of those points, this one would be over to the right by a and up by a, right? This one would be to the left, negative a, so x would equal negative a, and y would equal a, right? Now in the last case, we would have just said, we would have solved the equations, well, either what's inside equals negative a or what's inside equals positive a, but this time we're doing something different. This time we want to know where is this absolute value function that we've graphed? Where is it less than or equal to the y value of a? Okay. Now, vertically speaking, our y value, to get smaller y values, vertically we go up or down? Down, right? So if we want the values where this function, the places where this function is less than a y value of a, it would be everything below, and in this case, because we're including the equal sign, we would include the places where it also does equal a, the y values do equal a. But we're only taking the values that are below that horizontal line, right? It's kind of like the water line. That's the water line, and we want the parts that are underwater, right? So where is that? Well, that's this interval right here, isn't it? Everything between negative a and positive a, right? So if we're looking for just those x values, well, those translate to the x values between negative a and positive a, including the endpoints, right? And so here's where we make this transition. Once we isolate the absolute value, when I get an isolated absolute value is less than or equal to a number, instead of trading for two equations, we're trading for two inequalities in the form of an and compound inequality, right? So when the isolated absolute value is less than or equal to a number, then we know that whatever's inside the absolute value now has to be, here are my two inequalities. It has to be greater than or equal to the negative number, and it has to be less than or equal to the positive number. And then I just solve that compound inequality to get the solution, right? Do you see how that flows the same way that that absolute value equation problem did? Okay, let's try one. Well, once you do an example, you'll say, oh, okay, I got this. So what are we going to do here? We're solving an absolute value inequality. First of all, let's ignore what's inside, right? What are the two steps to get the absolute value isolated? Add one and then divide by two. Good. So if we add one, that cancels those guys and you get 2 times the absolute value is less than 6, right? Okay, now what? You said divide by 2, right? So if we divide both sides through by 2, we get the isolated absolute value. The absolute value of something is less than 3, right? Well, now finally we can look at what's inside. So what is inside? 3x plus 9. Okay. So whatever's inside then, how am I going to write that is, you can trade it with two inequalities in the form of an and inequality, compound inequality.
Like, make two.
So how do I do that?
3x plus 9 is less than,
So whatever's
3.
inside is going to be, well, the way we want to say this, you're correct, but the way we want to say this, it's going to be greater than negative 3 and less than positive 3, right? Okay, that's where we make our transition, so we get rid of the absolute value bars. Now we can solve this compound inequality to get our solutions, right? So what are the last two steps to isolate the x? Subtract 9, good. From all parts, right? We're solving a compound and inequality. Those guys go away, I get my 3x. Negative 3 minus 9. 3 minus 9.
-6.
And then last step, divide by 3. Okay, so the 3's cancel. I end up with an x. Negative 12 divided by 3 is negative 4. Negative 6 divided by 3 is negative 2. And so here's my solution in the form of compound inequality. So x is greater than negative 4 and less than negative 2. Those are all the infinite values of x that make this statement true. Okay? Make sense? Okay? So what about an OR? Okay, the OR is the same kind of deal, right? Oh, you know what? I got that backwards. Whoops. See what I did? I messed that up. Yeah, that's my virtual whiteout, I guess, my blue out. Okay, so we want greater than some of this stuff, right? So now we're going to take the other example. What if an isolated absolute value is greater than a number? Well, now we're looking for the region in the xy plane where what y values in my v-shaped absolute value graph are greater than a y value of a. Right? Here's my y equals a line. So now this is going to be all the stuff that's above the water line, right? Everything that's above that. So we see that if we look at the intersection of the blue half plane and the red absolute value function, it's over there, isn't it? Right? It's going to be to the left of the left boundary or to the right of the right boundary. And so here's our other case, right? When we've got an isolated absolute value function is greater than, I changed that. Yeah. Is greater than some number, then whatever's inside is either going to be greater than the positive or it's going to be less than the negative. Okay, so we get the other kind of compound inequality, we get the OR inequality in this case. So let's try one. So what do I do first?
Cover up the,
Yeah, let's ignore what's inside. Can't bother in the area. Gotta isolate first. So add 6. Only one step necessary to isolate the absolute value. So if I add 6, I get the isolated absolute value is greater than 24, right? So now whatever's inside, we can look. Negative 3x plus 21 has to be what?
Greater than positive 24.
Good.
Or less than, or greater than negative.
Has to be greater than positive 24 or it has to be less than negative 24, right? And I just solve those individually, right, to get my solutions. So in both cases, I'm just subtracting 21 and dividing by 3, correct? So what's that give me? What's that give me over here? If I subtract 21, I get 3, divide by 3, x is greater than 1. Right? Over here, I'm going to get negative 45. Right? On this side, when I subtract the 21, I get negative 45. What's negative 45 divided by 3? So there's my solution. X is greater than 1 or x is less than negative 15. Okay? There's an easy way to sort of think about this now. And this is, I'm taking you to your handout. So if we think about something, let's take the easiest possible kind where we're just taking the absolute value of x, just to kind of establish a way to think about this, theoretically, what's going on. The absolute value of x is just telling you the distance of between x and the origin, right? What's the absolute value of 5? 5, because the number 5 is 5 away from 0 on the real number line, right? The absolute value of negative 5 is 5, because that point is 5 away from 0, okay? So then if we want if the absolute value of x means a distance, right, and we want all the places where the distances between x and 0 are greater than or equal to 7, those are big distances, not small distances, right? So that makes sense that we're going to be doing this. Right? We want the distance, the absolute value represents a distance, and we want the places where the distance is away from the center is greater than 7. Okay, well, what about down here now? Here we want the places where the distance between x and 0 is less than or equal to 4, so those are going to be closer. So that's an and inequality, and that's an or inequality. Right?
Now I get it.
Okay, make sense?
Sure.
Make sense? So, I mean, this is the way, you know, these little handouts, this isn't bad, I don't mind this. The steps are, this is what we did. We isolated the absolute value, we created the two cases. Instead of two equations this time, we get two inequalities, either in the form of a compound and or a compound or, and then we solve each one. And then maybe you graph it, if you're asked to do so, right? So let's try just a couple more examples. Questions so far? Okay. So what about this one now? Don't say it out loud. Everybody think about this for a second. We've already got the absolute value
Is
isolated.
this a trick question?
No.
Okay.
No. So I want you just to think which one this is.
I don't know.
And or.
And.
Good.
I knew that.
Good. So whatever's inside then.
Okay. I have no idea.
Okay, somebody answer that. How do you tell? Well, what's the giveaway? Trey, what's the giveaway?
It's less than, it's and, if it's greater than, it's more.
There you go. If the absolute value is less than, fill in the blank, then it's going to be an and. If the isolated absolute value is greater than some number, it's always going to be or. Okay, and think why? Because the absolute value represents a distance. It's harder to see the distance when you've got something other than just an x in there, but I promise you it does represent a distance, right? So we want places where the distance is small here, so where we're closer to home. So that means we're going to have, you know, we're going to have a single and type of a graph, right, where it's bounded on both ends. If the distance is big, then you can either go really far away to the right or really far away to the left. It's going to be an or inequality like the ors on a boat, right? Where the graph spread out to infinity in both directions, okay? So then we end up with either 7 minus 4n, sorry, not either. We end up with, in this case, 7 minus 4n is what?
Less than 27.
Okay, it's going to be, that's one thing. What else? So this becomes an and, right? So 7 minus 4n is greater than negative 27 and less than positive 27. And then we would just solve this thing. What are the two steps? Real quick, might as well do this.
Subtract 7.
Subtract 7.
Divide by negative 4.
So we get negative 4n, negative 34, 20. No flips, right? All we did was subtract. Now what?
Divide by negative 4.
Divide by negative 4. So that gives us, in the middle, we get an n. How about over here? Negative over negative is positive, and that reduces to,
17.
okay, 20 over negative 4. And what did I have to do here? That got to flip. Divided by negative, so everything gets flipped. Is that a good answer?
No.
I think it's fine.
The whole thing around.
We're good.
I want to flip this whole thing around, right? Because when I write a compound and inequality, I want it to mirror the number line, right? So the inequality version of the answer matches up directly with the interval version or the graph. So I want to flip this whole thing around. I can't have my left endpoint being greater than my right endpoint. This doesn't make sense. So I'll leave the n in the middle. I'm going to put the -5 where it belongs on the left and the positive 17/2 where it belongs on the right. And what are the relationships? How is n related to -5? It's greater than or equal to -5. How is n related to 17/2? It's less than or equal to 17/2. And so if I were to use inequality notation or interval notation then, it's really easy to see that correlation, isn't it? Right? There's my left endpoint, there's my right endpoint. Okay. How about this one? So what's this one going to be, an and or an or? Oh, I'm hearing some there's a debate here. Here's debate for me. What's it going to be?
I don't think any of us have things like and or.
Let's find out. We'll see why. In hindsight, we'll look back and see why.
Oh, wait.
So what are the two steps in order to isolate the absolute value?
Add 1
Wait,
divided
let me
by
go
1.
now.
Oh, wait.
So those guys cancel. I get -4 times the absolute value is less than or equal to -20, right? Ah, okay. Is it? Okay, now look, when I divide each side through, those guys cancel. But look, I divided by a negative, right? So I gotta flip that guy around. So then I get the absolute value of something is greater than or equal to negative divided by negative is positive. And now whatever's inside, now what? And or? It's or, isn't it? Right, so now whatever's inside is either going to be what? Greater than or equal to +5, right? Greater than the positive, so it's going to be really far, it's big distances. We're going to go far away in the positive direction, far away, right? We want about further away than 5. So x plus 9 is greater than or equal to 5, or x plus 9 is less than or equal to -5, right? And if we solve those, I end up with the answers, solutions x is greater than or equal to -4, or x is less than or equal to -14, right? If I were to graph that one, well, if I were to write with inequality notation, I'd do this. This is the leftmost interval, isn't it? Right? I'd go negative, infinity, comma, -14 bracket, right? All values less than, meaning to the left of -14, or this one would have a left endpoint of -4 and a right endpoint of infinity. I mean, that's a dumb way to say it. That's the way you think it would go. Infinity's not an endpoint, is it? It replaces the endpoint. Make sense? Okay?
Both sides of the inequality not flip. Like they're there and then throw them on.
Say that again. I think it's a good question. Say that again.
The inequality,
Mm-hmm.
it flips with like the x plus 9 and then the -5, but
Oh, could it have been could I have written it the other way?
well, I'm just confused why the sign is the -5 is still.
Why? Okay, so
They didn't flip. Why did you flip?
they did flip.
Well,
They did flip, right? Well, okay, so I see what you're saying. How come this one didn't flip but this one did?
yeah.
Right, okay, because here's why. Let's go back and look. Let's review something. If we go back to this slide right here, right? So when we have an isolated absolute value is greater than a positive number, then what has to be true? Then what's inside has to be either really big and positive, so it has to be greater than the positive. So that sign's always gonna stay the same, right? Or it's gotta be very big and negative, so it's gonna be less than the negative,
Okay, yeah, I remember that now.
okay? All right, I'm gonna turn you loose. How much time we got?
6 minutes.
6 minutes? Okay, I'm gonna open up this assignment. Maybe you can just try to do a couple of them just to kind of get a little practice.
I thought 1.5 was already open.